Hello, in this video we're going to work on solving rational equations. The thing that makes a rational equation different than a rational expression, first of all, is an equal sign. If you have an equal sign, your objective is to solve for x. So that's kind of a basic place to start, but a worthy place to start. Let's start out with just a very basic sort of rational equation. 7 over x plus 3/4 equals 5 over x. There's two ways to solve a rational equation like this. The first is you could add these two items together and then use cross multiplication once you have one fraction equal to another fraction. The other way is you could find a common denominator and then just multiply by that common denominator. So I'm going to use this equation to do both and demonstrate both. The first thing I'm going to do is I'm going to find a common denominator, and we'll multiply by that common denominator. Since I had x and 4 here, what I could do is I could multiply by 4 over 4, and this by x over x. And this would give me a denominator of 4x, 28 plus 3x equals, if you multiply this by 4 over 4, you get 4x there, 4x on bottom and 20 on top. And now if you were just to multiply everything by 4x, the 4x's would cancel out, and you'd have 28 plus 3x equals 20. And then you would take away 28 from both sides. You're back to kind of a normal equation that you might have seen in Algebra 1. You get 3x equals negative 8. Divide by 3. X equals negative 8/3. So that's one way to deal with something like this. Another way is to add the fractions together and then on the left. And then once you have one fraction equal to another fraction, you can use cross multiplication. So let's do this same problem again. 7 over x plus 3/4 equals 5 over x. Again, we're going to find a common denominator here, multiply by 4 on the top and bottom, multiply by x, and you get 28 plus 3x over 4x equals 5 over x. Now what you can do, as long as you have one fraction, this is one fraction equal to another fraction, you can multiply these two things and set it equal to these two things multiplied. So 28 times x, 28x, 3x times x, 3x squared equals 5 times 4x is 20x. Just like always, we want to bring the all the terms into one side. So if you subtract 20x here, you get 0 equals, you get 8x plus 3x squared equals 0. And I need to factor this, so you can factor out an x, and you get 8 plus 3x equals 0. And then we actually have two answers here. X equals 0 there, or if you take 8 plus 3x and set it equal to 0, you take away 8, 3x equals negative 8, divide by 3, x equals minus 8/3. So this puts you in an interesting situation. This gave you two answers, and the original problem, the original one I did, gave you one answer. Negative 8/3 was in both. Whenever you solve using cross multiplication, there's the risk of an extraneous answers. An extraneous answer is an answer that appears to be an answer, but it causes the bottom of one of the original fractions to be 0, and thus is not an actual answer. It looks like it's an answer, but it's not. My original problem looked like this: 7 over x plus 3 over 4 equals 5 over x. And we just said earlier x could be 8/3 or x could be 0. Notice if you were to start putting in 0 here or here, that would be undefined. So this is extraneous. This is an extraneous answer. If you put in negative 8/3 there or there, that is okay. You can have a number, the number negative 8/3 in the bottom of this fraction. If you plugged it in here, it would come out to be the correct answer. So in this case, negative 8/3 is our only answer. With rational equations, whenever you kind of create a quadratic when there wasn't there one to start with, there's a high risk of extraneous answers. So that's one downside of using cross multiplication. Let's try another one. Let's try this one. Now, whenever you have a rational equation set up where it's already one fraction equal to another fraction, despite the risk of extraneous solutions, you really are best off just going for cross multiplication. 6 times x minus 2 equals x minus 2 times x minus 1. So let's just go for this and see where it takes me. 6 times x minus 2 equals x minus 2 times x minus 1. Now I'm going to just throw something out there for you before we continue. Notice how x minus 2 is in both terms, both of the left and the right side of this equation. It's going to be tempting to divide by x minus 2 and just cancel that out. If you do that, you are going to lose one of your two solutions, and it's possible that could be a solution that you wanted. So it's not a good idea to divide out something with an x in it at this point. If you had 6 and 6 on both sides, that's fine. You can divide that out. But don't divide anything out that has an x in it right now. That will cause you to lose solutions that you may want. So we're just going to kind of power through this. The distributive property 6 times x minus 2 will give me 6x minus 12 equals, use FOIL here, x times x is x squared. Minus 2x and minus 1x will make minus 3x. Minus 2 times minus 1 is 2. We're going to move everything over to one side, so we'll just take away 6x from both sides, add 12 to both sides, and we get 0 equals x squared minus 9x plus 14. That actually factors really nicely, thankfully. What multiplies to be 14 but adds up to negative 9, a minus 2, and a minus 7. X equals positive 2 and positive 7. And we need to check that and make sure in the original problem, does that cause any bottoms to be 0? And the answer is no. 2 minus 1 is fine. 7 minus 1 also is fine. Both of those will be defined. And if you just plugged in 2 here, you get 0 over 6 equals 2 minus 2 is 0 over negative 1. I'd say that works. That works. Then if you plugged in 7, 7 minus 2 is 5 over 6 equals 7 minus 2 is 5 over 7 minus. So that works also. So obviously there are two answers here. Again, if I had divided out the x minus 2, getting a little too anxious, I would have lost that answer. This one has two correct answers. So you never want to divide anything with an x out until you're all the way done. Let's try some more. Let's look at this one. Again, it's tempting to cancel this x out. I'm just going to be cautious and not going to do it. I'm just going to leave it there. I would like to write this as something that I can do cross multiplication with. or I could also, I could multiply everything by x minus 4 here, here, and here, cancel that out. I could multiply by x, here, here, and here. Either one will work. I think in this case, I'm going to go ahead and just make this a common denominator. So we're going to just rewrite this. We've got 4 times x minus 4 over x minus 4, and the right side's not going to change yet. So now these are the same denominator, x minus 4, x minus 3 plus 4x, plus 4 times negative 4 is negative 16. That's where we are. And now I'm going to do those two multiply together equal to these two multiply together, cross multiplying. And by the way, this is 5x minus 19 over x minus 4 is 3x over x. So as we cross multiply, I've got x times 5x squared minus 19x equals 3x times x, 3x squared. 3x times minus 4 is minus 12x. I'm going to group everything together. Take away 3x squared. I'm going to add 12x. So we get 0 on the right. I get 2x squared minus 7x on the left. You can factor an x out of that. So left over is 2x minus 7. And I need to know when that and that equals 0. So obviously, x can equal 0, or, by the way, when does 2x minus 7 equal 0? Add 7. 2x equals 7. Divide by 2. X equals 0 or 7 over 2. So you always have to come back and check. X equals 0. If you put in 0 here, that's, If you put in 0 here, that's fine. No x here. By the way, there's an x here. That would be undefined. So this is extraneous. And we're just going to say that is not an answer. And then 7 over 2 would not cause that to be 0. 7 over 2 doesn't cause that to be 0. So 7 over 2 is our actual answer. Give you a little happy face. Sad face. So again, check your answers. One other thing to consider: if you had canceled this x out, you might have, and you'd still had gotten 0 as an answer. You might not have realized it was extraneous. So canceling things with x out prematurely can just allow you to make mistakes. Okay. Try 1, 2 more here. Let's try this one. That's 3 over 1 for now. One approach that I'm going to choose here is because the denominators here are already kind of the same, or they are the same. This one's not. I'm going to just make this an x minus 4 by multiplying by x minus 4 over x minus 4. So you're going to have 2x over x minus 4 equals 8 plus 3 times x minus 4. This is 8 plus 3 times x minus 4. And that is 2x times x minus 4. This is what going to be 8 plus 3x. 3 times minus 4 is minus 12. That's kind of where we stand now. If you get the same denominator in both fractions. So, earlier when I had one fraction, this is one fraction equal to another fraction, I cross multiplied. Here, you can kind of skip that step if the bottoms are already the same, because if you have two fractions and they're equal to each other, regardless of what the bottom is, if the tops are both 0, or if they're both the same and the bottoms are the same, then the fractions are match. If the bottoms are the same and the tops are the same, the fractions are the same. And basically this equal sign says, hey, these fractions are the same and the bottoms are the same, so the tops have to be the same. So you can kind of just come down and say, this is going to be 2 equals 8 plus 3x minus 12. You can just kind of set the tops equal to each other and go from there. 2x equals 3x. 8 minus 12 is minus 4. Take away your 3x. Negative x equals negative 4. And that's x equals 4. And now you've got a problem. You've got a big problem on your hands. That's the only answer I got. And look over here at the original problem. If you were to put 4 in here and 4 in here, then that would be undefined. So this is extraneous. And that means this has no solution. And that's a result that's okay. Sometimes that happens. Not that often, but fair enough. You could have a no solution if you just have two things that are added together that are never going to be two things on each side of the equal sign that are never going to be the same. So that's an interesting case also. Okay. Okay, I want you to look at this one. So especially look at the right side. I'm going to write this over 1. Notice we have 2x plus 20, and this is 2x plus 8. I want you to notice that a 2 comes out of everything there. So we're just going to do x plus 10, on bottom x plus 4. And I told you can never cross out anything with an x in it, but if it's just a 2, that's fine. So we're going to just start this off as 2 times x plus 7 over x plus 4 minus 2 over 1 equals that. And that's going to make life a lot better. So now we have the same denominators on the left and right side, at least in these two fractions, not there, but we're getting there. If you just multiply this by x plus 4 over x plus 4, you are able to achieve that denominator that's the same everywhere now. So we're going to have x plus 4, x plus 10 is going to stay there. So we've got, let's just complete this. 2 times x is 2x. 2 times 7 is 14. Minus 2 times x. Minus 2 times 4 is minus 8. Uh-oh. We've got an issue on our hands potentially. 2x and minus 2x, those go away. Okay, I'm watching that. We do have an x over here, so that's going to kind of save us on in this particular case. 14 minus 8 makes 6 over x plus 4. And then we get x plus 10 and x plus 4. Again, since the bottoms are the same, that means the tops have to be the same. And you can see we're going to have a similar situation that we just saw. X is equal to negative 4. And that looks great, except that if you go back and look at your original denominators, that is something that would cause that to be 0 and that to be 0. So this is extraneous. And since there's only one, that is extraneous. Since there only is one solution that we got, that is actually a no solution problem. Okay. So just to wrap up, if you have rational expressions with an equal sign, they're a rational equation. Your goal is to solve for x, and you always want to check your answers to see if you might have an extraneous solution. I've shown you quite a few that do here, but I've shown you kind of probably a non-representative sample. Probably more of these don't have extraneous answers than do. I've just wanted to show you in a lot of cases where they are, so you kind of get used to it.